Good evening, my students. Now I'm going to discuss Doppler effect concept. Before going to the actual definition of Doppler effect, I'll tell you this with some examples. What is Doppler effect? In your daily life, the most of the times you're observing the Doppler effects. Example is a person is standing on the platform, railway platform is standing. You are waiting for the train. Now that one train is approaches you. Train is approaches. Train is approaches. As train approaches the observer, you feel that the pitch of the sound source, pitch of this sound source emitted by the train, it is as if it is increases, that is, as if it is increases. But in reality, the frequency of this source, whatever the latest sound is emitting from the train now, it is not at all increases. But you feel that the frequency is apparently it is what changing. Changing means it may increases or it may what decreases. When it approaches now, that is frequency, you feel that it is increases. F dash is greater than what it is. Suppose the train goes away from you, that is away from the observer. Now the train is going away. That is what train is going away. That is, it is departing from the observer. At the time, observer feels that the pitch of the sound source, pitch of the sound emitted by the train is gone, decreases. That is, F dash is less than what F that is. That means the apparent frequency, it may increase or it may what decrease. This effect what you're observing in your daily life. This is called as in what? Doppler effect. Define what is Doppler effect. There is an apparent change. There is an apparent change. There is an apparent change in frequency of the source. Frequency of the source. Frequency of the source. Sound emitted by the source. When there is a relative motion, this is important. When there is a relative motion between source and observer. Between source and observer. Source and observer. Some books they call it as a listener. Listener. But there is one standard formula is there. That formula is F dash equal to F into bracket V minus VO divided by V minus Vs. What is V? V is the speed of sound. V is the speed of sound. Okay. VO, speed of observer it is. Vs is speed of source. F is the original frequency or initial frequency of the source. Initial frequency. F dash is called as apparent frequency. It is called apparent frequency. Students, this is the most general formula. Then I will explain. There are different cases are here. This is the most general formula. What is that formula? Write once again. What is f dash equal to f into bracket v minus vo divided by v minus vs. Again, some important sign conventions are there. Otherwise, you will not generate the formula. It's difficult. Sign convention. What is the sign convention? First, suppose this is the source. Here is an observer. Students, always the V is represented, direction of the V is always represented from source to observer. This is the story of it. Direction of V is always from where? Source to observer. You are moving in the positive x direction. Next, what about VO and VS? Here, V is in this direction. Now, source is also moving in the same direction, that is, source is moving in this direction. And then, observer is also moving in the same direction, that is, observer is also moving in the same direction. Here you see, direction of V and direction of VS and VO, both are in the same direction now. Both are in the same. So that this is also positive. This also what? Positive. This second. First point is this. Second point is what? This. What is the first point? The direction of V is always represented from where to where you have to represent here. Direction of V is represented from source to observer. And next is what? Here. V is represented what? Like this. Okay, please. Now, here. Source is also moving from where? Left to right. Observer is also moving from where? Left to right. This direction and this direction both are same, so that it is what? Positive. Second point. Next. Third point. What is third point is? Here, V is fixed. It is from left to right. Now the source is moving from right to left. The source is going opposite direction. Vs. Observer is also moving from left to right. So that in this case, both are what? Negative quantity. Here, Vs is also negative and Vo is also what? Negative. When it is V and V is from where? V is from left to right. What about Vs? Vs is from where? Right to what? Left. You see, both are opposite. Both are opposite. This is negative and this is also what? Negative. Now, with this idea, now I will generate next. What is general equation? F dash equal to F into bracket V minus of VO divided by V minus of what? Vs. This is the equation. Okay. Now, case 1, and what is case 1? What is case 1? Observer is at rest. Observer is at rest. And source is in motion. Source is in motion. Source is in motion. Now you know the diagram now. Here, source. Where the source is moving? Source is moving towards the observer. Source is moving towards the observer. Source is moving towards the observer. Now, here is the observer. Observer. Now, observer is in what condition now? The rest condition. So that VO equal to what? Apply the same convention you apply. Here, V is always represented from where? Source to what? Observer. Now, this is the direction of what? We first point. Source is in motion. In what direction source is moving? The source is moving towards the what? Observer. So that it is moving like this. With what velocity is moving? Yes, this is moving. They told you, when both are V and Vs in the same direction, this quantity is what? Positive. So that Vs is what? It is positive quantities. This is positive. With what speed it is moving? Vs is fine. What about observer speed here? Is in rest condition. So that is what? 0. Now, the frequency heard by the observer is f dash equal to f into bracket v minus of what? Divided by v minus of what? Vs. This is equal to f into bracket v divided by what? V minus Vs. This is the equation. See here. When the source is moving towards the observer, the apparent frequency, it increases here. So that f dash is greater than what now? Increases here. F dash is what? Increases. This increase is possible when the denominator quantity is what? Less. That's why we are writing what? V minus Vs. Next. Second. This is A. B I am writing. Now source is moving. Source is moving away from the observer. Away from the observer. Away from the observer. Of the diagram now. Observer is moving away from the observer. This is what? Source. Here it is in what? Observer. In what condition here? Rest condition. So that VO equal to what? 0. No problem. Next. V is always represented from where? Source to what? Observer. This is it. Now, here. Source is moving. Where is moving? Away from the observer. So that he is moving like this. With what speed? Vs speed. Now look into this. Source is moving towards the left side, negative x-axis. So that this should be considered as what? Negative. This is negative. Because the direction of V and this direction, the direction of V and direction of this, both are in what direction? Opposite direction. That I told you. V and Vs, how they are? Opposite direction. Now I will generate the formula for this. This is the formula I am generating. What I can write? F dash equal to F into bracket. F dash equal to F into bracket of what? V minus of what? 0. Divided by V minus of Vs. Yes, correct. because Vs is what? Negative. This is equal to F into bracket V divided by V plus of what? Vs. Now look into this. Now source train is going away from the observer. Then certainly the pitch is what? Decreases. Here F dash is less than what? F dash is less than F. F dash is less than what? That's why here the denominator quantity is what? More. What? Plus quantity. Okay. Here, this is the most general equation here. By this, I generated the what? Whatever you need not depend upon the which is motion and in what direction it is moving and all that. This I can generate the equation. Next. Now, source is case 2 and case 2. What is case 2? Here. Source is in motion. Source is in motion. But observer is in rest. No, already discussed now. This is now. Source is at rest. Source is at rest. But observer is in motion. Observer is in motion. Say, this is the source. Here, observer is that. As I told you first, the direction of V is always represented. This is the direction of V. In your problem, which is at rest here? Source is at rest. So that Vs equal to what? Now the question arises, this fellow, observer, how is moving now? Here, observer moving towards the source. Observer is moving towards the source. Observer is moving towards the source. Okay. Now he is moving like this. Observe. Now apply the same convention of this. What is your general equation? F dash equal to F into bracket V minus VO divided by V minus Vs. Okay, fine. Here, look into this. V direction is like this. VO direction is like this. It is moving in the negative x direction, so that this quantity, it will be what? Negative. It is negative. It is negative. But this Vs equal to what? 0. Now, according to this equation, F dash equal to F into bracket V minus of 1. This is minus of VO divided by what? V minus of what? 0. This F dash equal to now F into bracket V plus of V naught divided by what? This is the equation. Now you are moving towards the train. That is, observer is moving towards the train. So the pitch of the sound is what increases. Hence, F dash is better than what? F. This is possible only if the numerator quantity is what? Plus quantity. It's more than this. Okay. Now this case. Next one. Now observer is moving away from the source now. Observer is moving away, away from the source. You are going away from the train, away from the source. Now, what is the scenario now? This is source. Okay, source is at what? Rest. So that Vs equal to what? 0. Next. Observer I am taking. Observer. Okay. Is an observer. And what is the direction of V? The direction of V is always represented from source to what? Observer. This is the V. He is now, observer is moving away. Away means like this, he is moving. He is going away from the train. With what speed is moving? VO speed is moving. How is moving? In the positive x direction is moving. This is what? He is moving in the positive x direction. He is moving. V is also in the same direction. So that this quantity is positive. It is positive. Now, the general equation is now what I can write. F dash equal to, I can write F dash equal to F into bracket. V, this is positive, minus of what? V naught divided by what it is? V minus of what? 0. This F dash equal to F dash equal to F into bracket V minus V naught divided by what? V. This is the equation. Now you see, you are going away from the train. Then the apparent frequency definitely F dash is less than what? Yeah. This is possible only if the numerator quantity should be less than this. That's why we are writing what? Minus. Okay. Now, two cases are discussed. Similarly, some more cases are there here. Here, both source and observer both are in motion. Whether are they approaching each other or are they what moving away from each other? Like that. The several cases will be there. Those I will discuss it in second video. Now stop.